Tasia, if you want to go ahead and start the recording. I guess it's already started. So everybody, welcome. My name is Nick Cody, and this is the workshop that's titled From Jupyter Notebook to Web Server, Containerizing Interactive Visualizations. So really the whole purpose of this workshop is to provide an introduction to containerizing applications, with the hope being that the knowledge here can get you started and curious about creating your own containers for your own applications and things that you might be interested in. So we're going to use a pre-baked example, go through the steps of how to create that into a container, and we'll take a look at doing some things with GitHub Actions at the end to build the containers for us, instead of doing it locally on our own machines. So anyways, like I said, my name is Nick Cody. I am a technical product owner in Sizzle in the TDD, and I actually don't know, it's technology development division, I believe. I'm getting a little tired of acronyms lately, a little burnt out. So anyways, technical product owner, what that basically means is I work with primarily the Sizzle Cloud pilot project, and my role there is to interact with different users in the scientific community to gather requirements, take those back to the technical team, and filter those down into, actual software applications and things that would be useful and will help accelerate based off of user requirements. So as part of that is the technical background. So I worked for about a dozen years in the private sector, working for a storage company doing data center administration. So my background is in data center administration. I was a network administrator for a long time, virtualization, Windows, Linux, storage. I've touched pretty much all of it. But the last few years has been focused mainly around containers and Kubernetes in particular. So I've been doing containerization stuff for probably the past 5 years. It's really cool technology. I really like it a lot. It's a different way to kind of shift your thinking. But ultimately what we're doing is kind of the same that we've always done traditionally. We just slim things down a little bit. So to get started, in the invite, in the meeting notes and everything that was sent off for registration, there is a long list of software that's required for this workshop. So just to get started, you need Docker or Podman to actually build the containers when we get to that point. If you have Docker installed, there is a container that has the prerequisites already installed in it. I'm actually going to use that container image to run this workshop. So if you do have Docker, you can follow along with me exactly, and I will give out that Docker container image in a little bit in the command to get that started. So outside of Docker or Podman, we need to have Git installed to actually copy in the code that we're going to use to containerize. We need Python and pip to install some packages. And also the application that we're running is Python based, so we need Python to be able to do that. What we're actually going to be looking at is a Jupyter notebook that has an interactive visualization in it. So we need Jupyter Notebook or Jupyter Lab installed to look at those notebooks. And then we need Conda and Mamba, which is included in a mini forge package. So these all went out previously. I expect that some of the software requirements might be some sticking points at the beginning of this workshop. So we're going to spend some time making sure that everybody's set up and is able to get all those different applications running the way they need to. There are 2 optional components that we'll get to, which is a GitHub account and a Docker Hub account. If you don't have those at this time, when we get to the point where I talk about those, you can sign up, and it's pretty quick to go through that sign up process. So we'll just take some time at that point if you're interested. That's mostly focused around utilizing GitHub Actions to do the container build for us. And again, instead of using our laptops, it'll make it so that when we just push code to a repository, it'll spin up a new container image and build it all for us. So goals of today are going to be working through a notebook together. And when I say together, I don't want it to just be me talking the whole time. I'd like to be able to get some kind of back and forth, especially with all the folks online today. Making sure that if there's questions, go ahead and feel free to raise your hand. If I don't answer you, feel free to just jump in and interrupt. I want this to be kind of just a free form, you know, let's feel comfortable working together through this workshop. So outside of that, what we're going to do is we're going to utilize the Python package panel to actually run a web server. We're going to do this a couple different ways throughout the workshop. We're going to run it just via Python. We're going to run it in a container, and then that'll pretty much be the bulk of it. So the next step is to actually build that container, right? One of our goals is to build the container that runs that web server. Then we'll jump into using GitHub to build that and pushing it to Docker Hub, which Docker Hub is a container registry. It's similar to, if you think of GitHub as a code repository, a place to store your code, Docker Hub is a container registry. It's a place to store your container images. That means that other people can go in there and look at what container images you have, and they can use them as well. So, and then ultimately the goal here is to get a basic understanding of the process so that it can be applied to what's interesting to you. Again, this is a pre-canned example that's come up a lot. I think it's valuable, but a lot of the concepts will easily transcribe over into different areas that, again, hopefully you find interesting, and you'll be able to at least find that runway to take off and do your own kind of development work on again, things that you find interesting. So, so to get started, there are instructions in the README file for this repository that's linked here. So I'm going to copy this link and drop it in the chat as well. It should have also been included in the email that was sent out, but just so we all have it, drop that in the chat here. And then I'm going to browse over to that repository myself. And we're going to take a look at the README file down here. So a lot of it's going to cover stuff that I already went through. So this repository is just a containerization example that takes an existing interactive visualization that's in a Jupyter notebook and turns it into a containerized web server. So again, here's all the prerequisites. It makes mention of if Docker's already installed, there's already a container image. So basically what I've done is created, let me make this bigger too. I've created a walkthrough Python notebook that basically goes through all of the steps. So we're going to
even bigger might be helpful for me.
looks
I
like
just got new glasses. Oh,
yeah.
that might be painful, but just one step bigger than what you had, it would be great. That's perfect.
All right. And it reformats that. There's stuff on the side. So we're going to go through that walkthrough notebook together. And in order to get that up and running, there's two different ways that we can do it. So if you want to do it via Docker, and this is the way that I'm going to do it, we're going to copy this whole Docker run command and fire that off. And what this will do, it'll start up a container that is Jupyter Lab that has all of the prerequisite software installed. And it also has Podman in it. So it uses rootless Podman. We do have to give Docker a privileged flag to allow it to actually build on your laptop, but it will allow us to build a container inside of a containerized environment. And I'll take a pause here too, because, we talked about there's 5 different basically software requirements that you all have to install before we even get started here. And the nice thing about containers is I went ahead and put all of those packages into a container image that then I can share with you all. And instead of having to install 5 different software packages, as long as you have a container engine on your machine, you can run this container and it comes with all the pre-installed software. So that's where containers really shine, right? It packages everything you need to run an application into a single image that you can share with people. And it's interfaced with your existing system through a container engine that are available on any different system. So it doesn't matter if you have a Mac, if you have a Windows machine, if you're running Linux, as long as you have that container engine, it'll interface with any of those operating systems without needing to install anything else. So that's really ultimately what the main benefit of container image is. And we'll talk about this more in the future. So I am going to go ahead and copy this Docker run command. And if you do not want to run inside of Docker, further down in the repository, there is some instructions on how to run this via your personal computer. That's basically cloning this repository that we're in with the git clone command, going into the going into the repository directory, and then starting the walkthrough notebook with Jupyter Lab.
Which would you recommend?
Either one is fine. Again, it's all ultimately going to be the same commands. It's just where you would prefer to run them. The Docker run command with the pre-built image, all the images and stuff that we're going to build will then be in that container. When we stop that container, you can remove it. Everything gets cleaned up, after you remove it.
Mm-hmm.
If we go through with Jupyter Lab, everything is going to hang around. We build off of a Mamba image, so that will get loaded in. We'll actually build the image, so those images will get stored on your laptop. So I think going through this a couple different times, I think running the Podman notebook container that I have highlighted here is probably the most straightforward way. But ultimately, the steps are the same.
Okay. What's the difference between Docker and Podman?
They're just, they're different container engines. They are basically completely interchangeable. The Docker commands that we run, you can run the same commands via Podman. Podman container image files typically look for OCI format. So later on in the workshop, you'll see when we do a Podman build command, we have to actually give it a flag saying format equals Docker instead of OCI, but they're in my mind, they're basically interchangeable. Docker is the most popular container engine.
Podman somehow more open source or more community driven or something?
It is, and it's funny because we're going to run Docker run command to get into a Podman notebook, and then we're going to use Podman inside of it to build the images. And that's mostly around Podman enables rootless capabilities, so you don't have to have root privileges to build some of these containers and things like that. So that's ultimately why recently I've shifted to Podman. For the majority of my container career, I've used Docker. Again, it's the most popular. There's a lot of documentation around it. It's mature. But starting to look into more HPC worlds, doing things without root capabilities, Podman's more suited towards that, better suited. So I've shifted within just the past probably like 8-9 months into using Podman more. And I will say, because we're using Docker for this initial command, because the Podman, rootless Podman, when you launch the Podman notebook, it doesn't do a good job of mapping over the network ports. And I probably could have spent a little bit more time figuring out what was happening there. It launches the container image, but when you click on the link to actually open Jupyter Lab, it says no connection found. So I pivoted over to Docker run with the privilege flag, because this will start the Jupyter Lab environment, and we can access that via the browser without having to do any kind of fancy extra configuration and these types of things.
Okay.
So my suggestion is, if you have Docker installed, if you have Docker installed in your machine, go ahead and use this Docker run command that I have highlighted here. If you have Podman installed and you don't have Docker and you want to use Podman, instead, we'll be using Podman once we get into the Jupyter environment. So I would suggest using the git clone method, going into that directory, and then starting Jupyter Lab directly with the walkthrough notebook. We are going to, when we run the Docker, this highlighted Docker run command, it does start up a Jupyter Lab environment for us, and we're going to clone the that same Git directory that was down below. So I saw your message, Orhan. Give me just a second.
I just kicked it off and it's churning. Seems happy.
All right, so Orhan, and yeah, and cool. There's a couple. If I don't see comments in the chat, feel free to unmute yourself and just interrupt. So I got a couple in here to kick off. Brian Bonlander does say, expect the Docker command to take a little while on your home internet. I pruned all of my images, so when I run this, it should take a little while here in the Mesa lab as well. So what it's doing is it's going out to that container registry and it's pulling the image onto your local machine, and it's going to run it. But the image is a little bit over a gig, I think, so it'll take a little bit just to download that and run it.
Tiny bit.
Yeah.
2 or 3 minutes.
Yeah. So, and then Ana Espinoza put a note in around thoughts on Singularity. So Singularity is another container engine that is touted for its rootless capabilities. It's used a lot in HPC environments, and my thoughts are, is it sounds like a really great option, and unfortunately I haven't had a ton of time to play around with it. So if others have information on Singularity that they'd like to share, or they think that it's a really cool tool that people should use, fully open to that. Again, this is supposed to be kind of a framework on introduction to containers, talking about the different container engines that are out there. So we've already mentioned Docker, which is probably the most popular container engine. Podman is a almost a drop-in, one-for-one, replacement for Docker. It's another container engine. Singularity, again, is another option when it comes to container engines. So there's a lot of different options out there. The nice thing with container images is it shouldn't matter what your container engine is. They should run across the board. And then it looks like we're getting some messages too about the unable to find image Encode Podman notebook. This looks like it's probably defaulting to like Docker. Docker is looking to find that image locally on your machine, and it's saying it can't find it, which makes sense. And then it's going to look out to whatever the default container registry is configured for your machine. So if it's Docker, it'll go out and look specifically to Docker IO, which is where I've got this image hosted. So that next command is pulling from Encode Podman notebook. So as long as it's pulling the image, you should start seeing some things kind of kick off, and it'll start downloading the individual layers of that image, and we'll work through that. So, and then I will talk about this a little bit later too. Let me go back to the actual slides. So if we look at this container image name, there's a couple different components in it. So the first bit is docker.io. That is the URL for the container registry. So, hey, this is saying, look at docker.io. There's a number of different container registries as well. So you'll see there's one that's spelled QUAY.io, which I've heard pronounced key or quay. I call it quay, but again, one of those funky ones.
Nautical type C.
Yeah, key. For part of the Sizzle Cloud pilot project, we run an internal container registry. So I'll touch on that later, but that has a different URL. So this is basically the container registry address. The next bit for me is ncody. That's my personal container registry namespace. So that's where my container images get stored when I put them into to Docker Hub. This would be different. You'll see later we're going to pull a Mamba container image for the container image that we're going to build. So that'll come out of the Mamba official repository. So this namespace will change depending on who owns the registry that you're looking at. The next little blip here, podman-notebook, is the name of the container image that we're going to take. So I have a number of different ones. Brian, we can use our NCAR Google identity for Docker Hub as well. So if you sign in to Docker Hub with your Google ID, it'll automatically kind of create a Docker Hub username that's based off of your UCAR Google creds. So we'll touch on that later too when we get there. Go ahead.
Are the Docker images also hosted on these what do you call it, repositories or
Container registries? Yeah.
Are there any limits to how much you can store, like for free, or do you have to start paying?
I have not hit a limit, and I have hit a limit with the GitHub Actions runner. Like when I get around 10 gigs of memory, it'll cut me off. I've pushed images to Docker Hub that are over 10 gigs, and I have not hit any limits. I'm sure that there probably is. I don't know them off the top of my head though. So I think that's if somebody wants to Google that, potentially see what the limits are. But good question, and then we'll think that's worth looking and getting a solid answer on. Mm-hmm. So outside of so after the container image name, the next thing we get is this colon, and I have included today's date. So we got 2024-06-20, and this is what's called the image tag. And you can think of this as a way to do version control for your images. So the thing about a container image is they're immutable. Once you build them, they don't change. The way that you change them is you update your instructions file, your container file, and you rebuild a new image. And that becomes the latest immutable container image. So as I mentioned previously, this is a great way to package all your software, all your requirements, version control all your packages. And if that container runs today, as long as you don't change it or rebuild it, it should run 10 years from now. All your different packages are pinned, all the versions work, all of that is hard-coded for that moment in time.
Provided your container engine hasn't evolved past that format.
And I would suspect the way that this is all orchestrated, it's that future kind of proofing in mind. The container engine works as the plugin to the actual container image. So the container engine handles talking to your operating system kernel, plugging in the network, those types of things. So it abstracts out that layer. So that container image interface is based off of some OCI standards that are developed across the board. And again, those other container engine platforms all follow. Again, as long as your container image runs today, it should run in the future without any issues, which makes containers a powerful tool. So that being said, I think I'm gonna.
What is the -P and the -IP flags? What do they tell you?
Cool. So these are specific to the Docker image that I created. So I'm actually gonna switch over my meet just for a second. And I'm gonna kick this command off myself because again, it is gonna take a minute to fire off. And then once I fire that off for me, I'm gonna go ahead and, all right, let me stop sharing before it'll let me share again. There we go. All right, so I like to use Visual Studio Code. It's a very similar interface to Jupyter Hub. It's a coding IDE. So it's similar to like PyCharm. There's a number of different IDEs out there. So this will be my shameless plug for Visual Studio Code. I really enjoy it a lot. It allows me to clone my repositories, gives me a little file browser. Again, all looks very similar to Jupyter Hub. It has some cool different extensions that you can put in here. So source control for Git, Docker one, it'll help out with different linting, those types of things. The other thing that I really like for it, I'm on a Windows system here, but I am a Unix person through and through. So down in the bottom, you can see that I'm actually running this inside of a container that is a Ubuntu system. Windows has this nice little Windows system for Linux application. So I'm running this whole Visual Studio Code application inside of Linux. So it gives me this nice little Unix terminal. In there, I will paste this command. So again, we've got Docker run. I have to give it this double hyphen privileged command in order to let it build containers inside. If I don't give it that, it'll basically say when I run the podman commands, it won't allow podman to build because it doesn't have privileges. So something I'd like to work on in the future is making this a little bit more straightforward so that we don't have to go through all these steps and host this in the cloud environment. But for today, I think this should be good enough. And again, it kind of, we're playing with Docker, we're playing with Podman anyways. So we'll get kicked off. The next thing,
given Podman root in your Docker image.
I'm giving it privilege. I'm running a rootless Podman container, but this container that I am running right now, I am giving privileges to my underlying operating system. I won't be able to run root commands in it. I think if I were a hacker, I could go in there and do some things, but we're not going to run this for very long. We're going to close it down when we're done. Again, it's there to make sure that we can build containers inside of this container. Typically, you wouldn't do this outside of if you were, again, running container builds inside of container. If you were running container builds on your laptop, you wouldn't need it. If you were running a different, if you wanted to run just a Jupyter container, you don't need it. It's just for the ability to build container images inside of a container. So the next thing that we're doing with that -P command, and then all those 8, is Jupyter Lab runs on port 8888, and we are mapping that to port 8888 on our local machine. You can map it to whatever port you want to. I just keep it consistent. When we run this, it's going to provide us with a link that we can click on that includes a token anyway. So we're going to use that link to launch the Jupyter instance. Then we have our container image name. And then the next bit, Jupyter Lab --IP 0.0.0.0 is just saying, hey, that's the command we're giving to the container to run, which is, I want you to start Jupyter Lab and run it on IP 0.0.0.0. And that makes it accessible to us on our local machines.
Okay. What is IP 0000? Is that like an internally routed thing, like 127 dot?
It's kind of like localhost. It's more of like a wild card, I think, where it almost like allows it to any address.
Okay.
So you can see I got the same unable to find image encoding podman locally, even though I provided, oh, well, that started up quite fast. So even though I cleared out all of my images previously, it downloaded this pretty quickly. So it said it was unable to find it locally. It pulled the image, it downloaded it, got it started, and then all this other stuff that's listed down below is the output from Jupyter Lab. So we're actually going to see the logs from Jupyter Lab running in our terminal now. And as part of that, we're going to see right here, it says to access this server, open this file in a browser or copy and paste one of these into your URLs into your browser. So this bottom one here is the one I typically like to use. This one up above is using an IPv6 address, I believe, which just overcomplicates things. So we're going to use this one down below, which we can see is on 127.0.0.1, which is the address for your local machine. It's running on port 8888, which is what we mapped it to on our local system. And then it's firing up a Jupyter Lab instance with this particular token. So we can't go to 127.0.0.1 port 888 without this token. It'll give us an authentication issue. So I'm going to go ahead and click this link, and then it'll open up a Jupyter Lab session, which I will switch the meet over to. And then I'm going to go through questions again, and we'll give it a minute to make sure everybody's Jupyter Lab session started up. So anyways, this is, once you hit the link, this is what everything should look like. Does not look like I can make that any bigger. There we go. I just have to click into it. All right, so we've got Ryan saying, if Podman is rootless, would that make it more insecure since anyone could run root commands, or am I misunderstanding rootless? So you're misunderstanding rootless. So rootless Podman means that you are taking away the ability to run as root. So basically, Docker historically has always required like the root user and root privileges to be run under the covers. So even if you're not starting up the container as the root user, you might be starting it up as yourself. And later on in this workshop, we're going to start up a container image as the Mamba user. But the root user doesn't exist. Root privileges don't exist inside the container. So this is more secure in the fact that you couldn't use a vulnerability or some kind of security breach to trick the container into becoming the root user. Because ultimately, if you were running this on like a shared cloud environment, if you could access the root user, you can technically hack into the underlying system that's hosting that container image and do some bad things. So we built, or I built this rootless Podman container to run this workshop to basically get away from the root user account. I don't have to do anything special, but there's an official Podman image that I build on top of, and we'll get more into building on top of other images a little bit later. And it includes all of that stuff for me right from the jump. So I don't really have to do anything. It assigns the Podman user some special user IDs and group IDs that are then configured to be able to run the Podman commands without having to run sudo Podman builds. And that's ultimately what we're trying to get around by running rootless, so that you don't have to run a sudo command or elevate your privileges to administrator to run these container images. So cool. And then Megan still did have a command that she got the Docker run launched, but the Jupyter server was asking for a security token. So that is why I had mentioned we have to click that link with the token in it from the terminal that we clicked before. And just to give an idea of what that looks like if we were to not do that. Now, I tried to do it that way, and of course, live demo, it just launched right into the session, and it might be because that token's cached somewhere in my browser or something, but switch back to this one. All right, so I think now, before we get kicked into cloning the repository and everything like that, I want to make sure that everybody's at the same point and we can get started. And if there's any other questions, those types of things, we can take a little break now. I guess one thing too I didn't touch on is we do have some sections broken into the workshop that are going to take a little bit to run. So I was going to use those as good built-in break times. So when we actually build the container image, it'll probably take about 5 minutes to actually go through building the whole container. So once we fire that off, feel free to get up and use the restroom if you have to. And I think maybe around 10:30, if we haven't gotten to a break, maybe we'll do another 10-minute break for questions, conversation, those types of things. And then we'll kind of reconvene at 10:40 maybe. So we'll cross that bridge when we get there. But just so you know, we do have some parts that are going to take a few minutes to spin. So feel free at that time to get up and do whatever you need to. So that being said, before we jump into it, are there any questions? Is anybody having difficulty getting to this point that we're at right now? And I think I actually closed the Meet link by accident. So let me fire that up again.
So it looks like the Jupyter lab is empty for me, and it looks like that's for you, so that should be expected, because I am getting a root exception encounter during get, unable to locate credentials.
Yeah, so that one, that is expected.
Okay.
I think it is an issue with one of the packages that's being installed as an extension. Let me share this. If I look at my terminal, I get the same thing. I get root exception encountered during get, unable to locate credentials. And if I go over here, on the left side, there's a couple different extensions that are loaded into this environment by default. We're not going to use all of them. They're included because I build other Jupyter images that include these extensions. And for the purpose of building this image, I kept things kind of the same as the way that I've done it with previous notebook images, particularly because I would like to try to see if we can get this into an actual Jupyter hub where you can build images inside that Jupyter hub. I did launch it on a cloud provided Jupyter hub. And it did not let me build images. So something that I'll look at in the future if we do this workshop again. I prefer to be able to give you all a link to a URL where this is already set up instead of having to run the Docker command on your own machines. But for today, that's where we're at. And again, we're looking at building Docker. We're going to be doing Podman container images, but container images in general. So getting started by having to run a Docker command is not the end of the world. So anyways, before we get started, is everybody here? Are there any other questions? Feel free to unmute yourself.
There was one.
Yeah, hi, I tried the Docker command and I'm getting some permission problems. Maybe I missed what you said about clicking on a link.
Yeah, so let me actually switch over the share just for a minute because you're not the only person that had this issue. So just share my entire screen. So what you'll see is we had a mention about this error root exception. This, I believe, is actually linked to an object storage extension that object storage browser extension that we have. But what we want to do, what you pasted was this link right here. So you can copy and paste. I would suggest copying and pasting this one at the bottom. And you might actually be able to hold control. It might on a MacBook, I think it'd be command, and then click on this link. But you need to grab the whole thing, including the token, and then put that in your browser, and then that should open up a screen that.
Okay, there it goes.
Apologize for the infinity. Yeah, so then we should be in something that looks like this, and then we'll all be working through this together. Any more questions at this point? And apologies too, I accidentally closed my Meet and reopened it. So the previous questions, I think I answered them all, but I lost my history. So the last one I had, or the only one I've got in there is from you, Patty. But I think I had hit everybody else's before that. Cool. So the next step that we're going to do is to clone the repository that we were looking at earlier, the README file that we had. So we're going to go ahead and clone that. There's a number of different ways to do that. If you're in the repository, like we were earlier, if you have this link from let me drop this link into the browser or into the Meet chat. So that in the Meet chat is the link to the URL, like the website for this repository. Inside the website, you can go ahead and in this green box that says code in the dropdown. If you click that, it'll say, hey, you can clone this with this HTTPS link. We're going to use that HTTPS link, which again, I'll plop this into the chat. It's the same as the URL. It just has .git at the end of it. So there's a number of different ways that we can actually do the git clone command. You can do it from the terminal. So inside of Jupyter Lab, there's a button down at the bottom of the launcher for a terminal. But I'm actually going to make use of one of these nifty extensions here on the left. So we've got this one that's shaped like a diamond with a little branch on it. This is the Git extension. And from here, it'll let us clone a repository. So if we go ahead and click the clone repo button, this will pop up. We can paste that .git link in there and then hit the clone button.
And include submodules.
Yeah, the default settings that show up there are fine.
Okay, and not download the repository.
No.
Okay. Successfully cloned. Woohoo.
Awesome. So once we get that in place, we'll just navigate into the actual directory that we just copied. And then down here at the bottom, there's this walkthrough notebook. So we're going to open that up, and this will be the bulk of the content that we're going to be going through today. So in the future, if you want to come back to the stuff that we're doing, it's all here in this walkthrough document. So again, for posterity, those types of things, you can come back to this repository and you can do that. Actually, sorry, everybody. I'm going to change course here, actually. Let's go. So we can clone this repository. We can go through the walkthrough ourselves. We can do everything. That's great. But later on in the workshop, if you're interested in following along with creating a GitHub action, and doing some GitHub automation. Instead of cloning the repository, what we'll want to do is actually fork it to your own branch. So if I click on this link, it's not going to work because I'm the owner of this repository. So from this dropdown, I can't click my own username. So what I'm actually going to do is see if it'll let me switch over to my personal email address. The Meet won't let me, so I'm going to switch that real fast to my entire screen. And then I'm gonna fork this repository, and I'm gonna clone my fork instead of the original one that I just shared. So my apologies for misleading everybody on that, but this will be better in the future if we go this route. So in here you can see this is I am in that same Nicholas Cody NB to container repository that I shared the link to before, but instead of hitting this code button to get the link, what I'm going to do is up here there's fork instead. And what this will do is we'll create a copy of this repository in my own personal GitHub account. So I can work out of that. I can push my own changes into there. It's an identical copy of where we're starting from this repository. So again, sorry for misleading, but I would click this fork button. You'll see my personal GitHub account is named Gingy. And then if I want to, I'm gonna just append my personal GitHub account name on the end, just to know that this is different. So
Running me through a verification step when I go to the GitHub thing.
when you go to fork it,
Yeah,
what's it saying?
it's saying it's going to email me a key, and I'm going to have to paste it into a window, and then so it's doing two-factor authentication on me to get into my UCAR GitHub.
Okay. I think that's basically it's saying, will you approve your UCAR account to have access to GitHub? I believe that's what it's doing.
Yeah, probably. And
It's, do you authorize the UCAR authenticator to act on your behalf, basically?
that's probably okay. Who knows?
Do you have a GitHub account?
Yeah, through UCAR.
Or you do?
Yeah, I do.
Okay. And when you click the fork, it was asking you to?
Yeah.
Okay.
So now here it's giving me a verification code. I could go ahead and follow that trail.
Has anybody else seen that two-factor authentication for forks?
No, just because I was using my personal GitHub.
Yeah, I don't have any. Well, I no longer have a personal GitHub.
No, and that's fine. It's I've used my UCAR account too to fork, and again, for the purpose of this, I got to use the personal one just because I'm the owner of the existing repository. I would think that that's okay.
Yeah.
And it might be a security setting that you possibly have in your actual GitHub personal settings. Just say, hey, when you try to do this, prompt me for two-factor and just enhance security. There's always a good thing. So anyways, you can see I've got now this new owner is my personal account. The repository name, I've added just my own little tag at the end. You can keep it the original one if you want to. And then we only need to copy the main branch. I do have additional branches, but we only need the main branch for what we're doing. So I'm gonna go ahead and create this fork.
I guess I still do have a GitHub. Okay, right.
And cool. So this is now a copy of the original repository, but in my own personal GitHub account. And so I'm going to use that same code button there to drop down, and then I'm going to grab the Git link for the forks branch instead of the original one. Find. So back over in the Jupyter session, I'm going to go ahead and delete the repository that I cloned previously, just to avoid some confusion on my part, because I will start working out of the wrong one by accident. And then this time there's this nice little button up here.
So how do you delete that again? I'm wanting to do the same thing.
I just clicked on it and hit my delete button. But you should be able to just right click it and hit delete as well.
Okay.
So yeah, if you right click it, there you go. That third option down is delete.
Okay, and that's the NBviz to container.
Yep. And at that point, there should be nothing in there. And that's the nice thing with the Git repositories, right? We're keeping all of that code in a central place. I can delete that. I can reclone it again in the future, save space. It allows me to kind of come and go as I want to. If my laptop were to, fall down the stairs and break, I can go to my repository and get everything that I've been working on. I don't have to worry about losing anything that was stored locally on my laptop. So anyways, I'm going to click this button this time. It brings up the same extension, and then I'll paste in my forked branch there and copy that in. And then open that directory, open the walkthrough, and it'll prompt for a kernel to select. We're not going to really use any of the actual kernels, so you can just select the default one, which is the Podman based kernel.
So now I'm trying to clone my personal one and it's saying failed to authenticate.
Did you grab the HTTPS link and not the SSH link?
Well, let's see. Oh, I just have git at GitHub as my link. Yeah, so, yeah, failed to clone. Okay.
Yeah, so again, in the clone options, you'll get some different ones. There's a GitHub CLI, there's SSH. SSH requires you to have SSH keys configured. And then there's HTTPS, which should just be secure and require no kind of authentication or keys. I could be mistaken, but again, it might be different depending on how your particular GitHub account is set up. But through HTTPS, I've never been prompted, I don't think, for authentication.
Yeah, I just tried the same thing via the terminal and it's saying permission denied public key.
Here, I'll come over and take a look. Is anybody else having an issue cloning their fork?
All good here.
So I think it did a confusing thing. First of all, it wanted me to clone via my UCAR account.
Oh, so yeah, so this link is just a little different. Let's go back to the GitHub page.
Okie dokie, GitHub page. That's
No,
not the one.
No.
No, that's not the one.
Are you signed into your personal one there? Let's go up to the GitHub and then scroll up, and I'll just click the sign in button. Even if you're signed in already, it should just redirect us.
Okay, sign in GitHub.
Yep.
I don't even know what the heck this is an old.
And if you have the UCAR one open in a different window, we should be able to use that. Where you went through the fork earlier.
Well, now it's confusing my UCAR GitHub with my old personal GitHub that I no longer use. So what could that, let me see if I do git dot, this is the one I usually use.
I should be able to just figure it out too based off of, so go back to the lab. So basically what you're gonna do is do an up arrow and bring that back up. And then let's go left all the way back in between donut. Sorry, it looks like donut.
It looks like donut. It looks like donut to me.
Delete the colon, add a /, then go back a little bit more, and at the @ we're going to get rid of that git @ and then do HTTPS. Yep.
Colon
/. Yep. And then hit enter.
Interesting.
Yep. And then if you click back on the file, on the left little taskbar thing, back up to the file explorer.
This guy.
Cool.
Yeah.
And then you'll see that in there. Cool. So you were using the actual Git at link, which would require authentication. If you use that HTTPS link instead to clone from, that doesn't require any authentication because you can't ultimately make changes without authenticating through Git.
Okay. Yeah, I was just cutting and pasting the thing after I forked.
Yeah. And that might be like how to actually initialize the Git repository in an IDE, like actual code browser. So the HTTPS link is all we need for this. So I think you're good. Everybody else good up to this point? Let me make this a little bigger now too. So we'll skip down. We've covered a lot of these prerequisites and stuff. Again, this notebook is there as a complete walkthrough. So copy a lot of this. I did include some of these nice things to make sure that the prerequisites are installed. So if you launch the Docker container that I provided, all of these will give you the versions that we're looking for. So we know that we've got everything that we need. We didn't get any kind of command not found response from that. So we can continue to move forward.
So in the walkthrough, well, now it's telling me select kernel pod and base.
Yep, and that's fine.
Okay.
Again, we're not really going to use that kernel for this notebook. We are going to create a new one, but we're going to use that in the terminal to build our container, or to run the actual server and those types of things. So, yeah.
I just thought I'd mention for people who don't use Jupyter a lot, it's Shift Enter. You click on one of those cells and then Shift Enter will run it.
Thank you, Brian.
Yeah. That's very helpful. Yes.
It is extremely helpful. So Brian actually is the one that taught me that too. So it saved me a lot of time from going, clicking in this box and then going up to hit the play button and these types of things. So, so now we're going to get into actually grabbing a existing Jupyter notebook that has an interactive visualization already in it. We're not going to take the time to go through creating an interactive visualization or anything like that. So what we're going to do is we're going to take a cookbook that exists as part of Project Pythia. So if you're not familiar with Project Pythia, it's a great tool set to provide an introduction to Python, some of the Python packages that are used for data science, so like Xarray and NumPy and a lot of the different packages. But it also contains these things called cookbooks, which are created by the community as examples of how to do things. So there's cookbooks around, like CMIP6 data and how to manipulate that, intake libraries, how to use intake to get catalogs. So there's a lot of content in Project Pythia. If you're not familiar with it, I did include links inside this notebook to take you to the cookbooks page. And we're actually going to use an existing cookbook that was authored by Pritam Das, who was a SciParks intern here at NCAR last summer. So he developed this notebook that was turned into a Project Pythia cookbook. And it's a interactive visualization that uses Sentinel-2 satellite images. And he created a interactive visualization to basically look at those satellite images in an interactive way. So we'll take a little bit more of that we'll take a look at that here in a little bit. But I just wanted to give a shout out to Pritam for putting this together because we are going to borrow that for our example to go through. So the next step that we're going to take is to actually copy that content. So we're going to copy the cookbook into this Jupyter lab as well. So I've got this command built in here, so you can copy and paste this without the exclamation point, and paste this into the terminal if you want to. That exclamation point though, allows us to run inside of Jupyter Lab. So if you click on this, this code cell, hit Shift Enter and run it, it's going to go ahead and run that command for us. And Jupyter doesn't do a fantastic job of updating the file browser. So you can see that it did pop up. This is the folder that we just cloned. But if for some reason it doesn't pop up, they have this refresh the file browser button up here. So you can just click that. And so what we just did was we cloned another repository inside the repository we just cloned. So we did this mainly so that we can take a look at this interactive visualization notebook that's already been put together for us. So if we click into this interactive Sentinel-2 and then into the notebooks directory,
Interactive.
there is a data intake MS planetary computer notebook. And this contains the visualization.
Oh, bother.
Excuse me.
Okay. Select. Okay.
So this is the notebook that we're going to be looking at containerizing. Again, this is going to be more of a walkthrough on how to create the visualization. So it's going to take you through the steps of what was done to create the visualization, the different steps. It's much more of a learning tool, again, on how to create an interactive visualization. It was not designed to actually be a web server. It still works, but you'll see when we actually fire it up as a web server, it takes a little bit to load the content and these types of things. And that's because it was designed to be, you know, a teaching tool. So it's going to run some print commands here. We can see it's going to output some things that ultimately, if we were actually going to develop a web server that we wanted to put out there, we would refactor this code a little bit. But in terms of showing off how to containerize this, it's a great example because it does have that interactivity at the end here. And I'm not going to run this notebook right now to see that interactive visualization at the end, mostly because we're going to run that twice as a web server. We're going to run it as a web server. We're actually going to run the notebook as a web server, then just the interactive piece of that as a web server, and then we're going to containerize that interactive piece. So if you are interested in how to create the visualization, that type of thing, I would suggest taking a more in-depth look at the actual notebook itself outside of this workshop. Again, it's a great foundational piece just to kind of get started. The Pythia hackathon where we create cookbooks actually happened last week, and we created a visualization as part of that. And we borrowed a lot of the stuff that was in this data intake planetary computer notebook. So the cookbook itself that we just cloned comes with its own environment.yaml file. Now, this environment.yaml file contains all the Python packages that are required to run that notebook and that application. So we've provided this nice, neat little Jupyter environment, but it doesn't contain all of the software needed to run the notebook itself. So that's one of the reasons we're not going to run the notebook right now. If we did try to run it all, it would throw an exception that it can't find one of the packages, which is fine. That's to be expected. But what we are going to do is create a new environment so that we can run it as a web server directly out of this Jupyter environment. So we do this with the Mamba env create -f command here. And what this is doing is it creates a virtual Python environment that contains only the packages specified in that environment.yaml file. If you're not familiar with what that environment.yaml file looks like as well, it's contained in the base directory of this Interactive Sentinel 2 repo that we cloned. And I'll open that up just so we can take a look, but it's basically just a list of Python packages. So these are all the different Python packages that are required not only to run the actual application, but some of the ones that are required to actually host it in Project Pythia as well. So some of these ones like the Sphinx, this one down at the bottom, Sphinx Pythia theme, is required to just run it on the Project Pythia website. It's not required for the actual application. So just wanted to point that out. The rest of these are required. So what we're gonna do is, again, we're gonna highlight this Mamba env create command, and we're going to create this Mamba environment. So depending on where you're located in the file browser on the left, go ahead, Orhan.
Hey, Nick, I was just going to say, so I checked the containers conda version and it is 24.5.0, right? So I think with this conda version, there shouldn't be any difference between running the commands with Mamba or conda, because with this conda version, I think the package solver under the hood is defaulting to Mamba. Would you agree with that?
I honestly, I've been getting that the containers I've been running have been giving me a conda version can be updated thing. So I just threw that in and I haven't played around with the latest conda version. So if that, I'll trust you on that one, Orhan.
Okay. Yeah.
So I've got a little note here that speaks to what Orhan just talked about. So we were using Mamba env create instead of conda env create because Mamba is optimized with some C++ code to actually solve the environment a lot faster. And when I say solve, what it's doing is it's looking at all these different packages and their interoperability together to figure out which versions are required so that all of the software can play nice together. You can easily run into, if you were running pip, for instance, to install all these packages, you can easily run into version mismatch, which is kind of a nightmare. So Mamba/conda does that for you instead. So Orhan, I'm going to go ahead.
Is there any downsides to Mamba? Because it sounds like everything that's problematic with conda that's like resolved with.
To be honest, like I have used Mamba exclusively for creating my environments because it's been so much faster. But to Orhan's point, if the new conda version is now defaulting to Mamba for that solving piece, then it should be used. I've found that Mamba works very well for actually creating the environments. But then when you go to activate them with Mamba, it creates some headaches. So typically I do Mamba environment create, and that is a lot faster. And then I'll do conda activate the environment when it's done. And that's mostly around like Mamba just throws some kind of errors and that kind of stuff. So
if you've installed Mamba, have you also installed conda, or do you have to install both?
So if you installed it via the MiniForge link that I provided, that MiniForge is conda and Mamba together.
Okay.
And if we actually scroll up, I use that same installer script inside this container. So like I run the same commands to install inside this container version. And you can say when I run Mamba version, it's outputting both Mamba and conda. So anyways, I did include that note about Mamba being faster. But again, I haven't even had time to use this new version really. So to Orhan's point, if conda under the hood is using Mamba now, this is not applicable anymore. So Conda should just be just as fast. So anyways, what I was getting at is we're going to start up a terminal to run this Mamba env create command. And depending on where you are in the file browser here on the left, the terminal that you open will be inside that directory right from the jump. So you can see right now we're in the mbviz to container-gingy directory. So if I scroll down and open a terminal, the bash shell here doesn't give me a nice look of where I am. So if I do a pwd to print my working directory, it'll say, hey, you're in home Jovian mbviz to container-gingy. The environment file that we're looking for, so if I do a mamba env create -f, which means from file, I have to go into the interactive sentinel-2 directory, and that's where my environment.yaml file is. Tab will work in the terminal to auto-complete. So you could see I only did like int, and then I hit tab, and it auto-filled out the rest of that directory name for me, and then I hit env tab, and then it filled out the environment.yaml.
So how are you getting your terminal here? I've lost the terminal.
Yep. Go. So anytime there's this plus button at the top of the Jupyter lab.
Mm-hmm.
So if we click on that, it's going to open this launcher, is what they call it inside.
And now
then
we've got the terminal.
scroll down to the bottom, and that's where the terminal is.
Lovely.
Yep. And again, it will open up whatever. It will place you into whatever file or into whatever directory you're working out of here in the file browser.
Yeah.
So again, if I were to go into the interactive sentinel-2 and open a terminal and do print working directory, now I'm actually inside of that. So I would just do mamba environment create environment.yaml file from inside of here, because this directory contains that file that we're looking at. So
so get into interactive sentinel-2 directory and then do the thing.
Yep. And so again, the command is conda env create -f, and then the path to the environment.yaml for the interactive sentinel-2 notebook.
So you're wanting us to use conda instead of mamba.
Yeah, apparently we'll see how this goes.
Well,
But this is also, I mentioned at the beginning, there's going to be a couple of times where we're going to run a command and it's going to take a while to complete. So this is one of those steps. So once we hit this, probably a good time to take a break. If you want to go, take 5 minutes, and maybe we'll let this run. I'm going to hit enter on mine. So we'll let this run. Feel free to take off, and I think we'll pause for questions, conversation, and we'll come back at 10:23 is when we'll start going through the next bits of the content.
okay. I'm right away running into a bug or an error.
What'd you get?
Environment not found. Home Jovian mbviz to container.
Yeah. So do conda env create -f, then do mbviz to container. So basically the environment.yaml file wasn't in your current working directory.
Okay, where?
So you can do an ls to see where you're at.
Yeah, so.
Okay. So yeah, you should be able to do, if you just do up arrow, yep, and then delete all the interactive sentinel-2 / stuff.
Oh,
because
okay.
you're-
Yeah, I see
yep.
what you're saying.
Yep, you're in that directory previously.
Right.
So awesome.
Okay.
Hit enter. And yeah, this is going to run
It's gonna
for
take a while.
a while.
Okay.
So again, good time to take a break. It'll be probably about another half hour before we get to another spot. So I think I'm going to skip the 10:30 break. Since we're pretty close to that now, we'll just take 5 minutes here. And then we'll take a little bit longer break, potentially around like 10:45, 10:50. And then I'm still relatively new to Conda and Mamba. It's used fairly heavily here. It's great in terms of managing your Python packages. So again, what it's doing here is we provided it a list of Python packages that we wanted it to install. It's going to go out and look at which different versions are compatible with each different version, create a common denominator, basically of all the different packages that play nice with each other. And it's going to install all those different versions to make sure that we've got an environment where all the packages work together and
So you're just going out to the web, to the latest, or to all the versions of the packages. And if somebody messes with the package installer or updates a new version, you know, like that thing which brought down the web a year or so ago, that'll impact this.
yeah. So just as an example, let's what did I hit recently? Okay, I hit an issue with bokeh. And as I was preparing to do this workshop, going through some things, and I ran command to actually launch the web server, and it spit out at me that there was no, I can't remember the exact syntax, but it was basically like they couldn't find bokeh. And it was an issue with one of the versions of this Jupyter, I think it was Jupyter Lab, but it was an issue with that version. And I needed to upgrade it to a later version in order to actually get the application to work correctly. So that's something that I could pin inside this file. You can see right here that it's saying for Python, use a version that's greater or equal to Python 3.9. So it will solve the rest of these knowing that it has to run Python 3.9. But for instance, let's say somebody upgraded bokeh to be, I don't know those versions off the top of my head, version 5, right? But version 5 doesn't work with the panel version that I'm using. So Mamba will actually go out and figure that out and say, well, in order to run with panel version 4, bokeh needs to also be version 4. So even though the latest version is version 5, I'm going to use version 4 because they work together.
Yeah. So you got library hell and it's trying to solve it for you.
Yeah. So it's taking care of that library hell for us.
Yeah, except when it doesn't. I mean, I've wrestled with pip a lot, and pip.
So pip is different. So if you think about, so Mamba and Conda create virtual Python environments. And when I say virtual, right, they're real, but they are segregated instances of Python environments that you can load or disload. So you can have different Python environments on your operating system and switch between them. So you can have different, you know, like something I may be doing requires a newer version of Python. I can switch to that environment with the newer version. Now, pip typically will install packages into your base operating system so that they're available to everybody. Right. And this is where you can get into that. Pip can't solve, you know, this package depends on this package, which depends on this
certain
package.
things are just pinned and we can't do anything about it.
And that's why we use Mamba instead of pip, is to circumvent that issue.
So Mamba can say, okay, we need a new Python, whereas pip can't.
Yeah.
Because pip comes with the Python version.
Yeah.
So what's the difference between mini Conda and Mamba? And well, I guess Conda, what's Conda and mini Conda then? That's all, it's all different containers, but they're containerizing different subsets of things.
I think it's mostly what comes with the software stack at that point. So like mini Conda potentially only has like the bare minimum, and somebody else can correct me on this too, that's much more familiar with using Conda and Mamba and the different flavors and iterations. But my general understanding is like something like mini Conda would only include certain packages. The mini forge instance that we provided earlier with Mamba and Conda, so that's a thicker package, right? Python itself does have the concepts of virtual environments, which is what basically Conda and Mamba are doing, but they become a real pain to manage. So you can activate a Python virtual environment and do a pip install into those virtual environments, but it doesn't handle package dependencies or anything like that for you.
But Mamba and Conda are still not in a complete container. They're not in a Docker container. They're just fussing around with,
Software.
so they're in the base OS, but they can actually swap in different versions of Python and everything. So it's kind of like a container light. It doesn't change the underlying OS, but it does change everything Python.
It doesn't change everything Python. Your base installation will still stay the same. It will change the environment that you're working in. So again, so in here I can do a Conda environment list, and it's going to show, hey, I've got 3 different Conda environments actually, and each one of these contains different packages. So this allows me to switch different environments. So like I would say I wanted Python 3.9 for doing something with some old code. And then I was working on something else that uses Python 3.12. Well, instead of installing and doing an uninstall of Python and reinstalling 3.9 and then upgrading that to 3.12 to go back, like I can put that all in a virtual environment or like a contained Python environment that contains whatever I need for that particular instance. And I can activate that, which we're going to do here in just a second. I can activate that and then get access to all those packages, and then I can switch around and get what I need for the application that I'm doing without it upgrading anything on the base OS.
Okay, so Conda activate sounds to me like it just fiddles symlinks so that it's your user bin Python is now pointing to Python 3.9 or
And that's basically what it does, right? It points the path when you try to run an application at a different path, right? So if I do,
so you've got a really complex hierarchy of library areas for different versions of Python and different versions of Python. And Conda activate just sets up a bunch of changes environment variables, changes symlinks, does whatever it takes to get you pointed to this Python with those packages.
yeah, so we'll go into the next section, and I think you'll be able to see based off of this command I just ran. So I did which panel. So I do have panel installed in this Podman base, but you can see that the panel that it's running comes out of serve Conda Podman base, which is the name of my Conda environment, bin panel.
Okay, what's panel?
Panel is a Python package that we're going to be using later to actually run the web server. It's a Python module.
Okay, it's a Python module which does HTTPD serving.
It does HTTP serving, yes.
Okay.
We're using this one because it was baked into, that's what the Interactive Sentinel 2 cookbook used to develop its dashboard. Basically, it's using panel. It creates the plot. It uses little sliders and makes it interactive. So that's why we picked it. There's a number of different web servers out there. Panel does not have to be the one that you pick. Again, later on, you'll see that we're using panel, but a lot of the containerization principles that we're going to go through would apply to if you were using Flask, for instance. Flask is another Python-based web server.
Mm-hmm.
There's a number of them. There's Flask, Django. You can use Fast API. There's Panel. There's a whole bunch. Panel is a HoloViz product. There's a number of different HoloViz products that you can use as well to run a web server.
HoloViz being some company or some software group?
Yeah, I believe so.
Okay.
So it's just a piece of software that we're going to use. And again, it's Python based. So this is building a container for a Python based web server. But again, the principles are fairly, you can use them for different ones. Like if you wanted to start like an Apache web server inside a container, it's a little different. But you would use an Apache web server container that actually comes with everything that you already need under the hood. So you just copy your files in. Anyways, I think the next step is to activate this environment once it's done. So we'll go ahead. Close this one out. we're going to go ahead and run that conda activate is2-cookbook.dev inside the terminal. It can be any terminal. Doesn't have to be the same one that we just had open. When we do that, we're going to see that the Podman base has now changed to this is2 cookbook dev in parentheses, which means that we are now working in that conda environment. And if I do a which panel now, you can see that it's actually, it uses the tilde here, which is a shortcut for your home directory. So inside Jupyter Lab, we are in the home/Jovian home directory. Jovian is just what Jupyter uses for its default username. So, but then it installed the is2 cookbook dev conda environment into my conda envs /is2 cookbook dev. Then in that bin file, there's a panel application. So you can see that panel command is available in both environments, but when we activate it, it's looking into a different default path.
Yeah, so when you actually crank up Python and start saying import this and that and the other, it's looking at the new symlinked
Yep.
area and
Yep.
yes.
Yeah. So we are now inside the that is2 cookbook dev, which contains all of the Python packages that we need to run that notebook, which we need to run that visualization. So what we're going to do next is we're actually just going to run a panel serve command to serve the whole notebook. And we're going to take a look at what that looks like. So we're going to start a web server right now as the next step. And this is going to be different in case anybody is actually running this on their local system and they're not running it in the Docker Podman notebook container image that I provided. It is a little bit different. So I do have a section here about running on your local machine. The command is just panel serve and the full path for wherever you're at to that notebook. And once that's up and running, this link will work to take you to the dashboard. Inside the Jupyter container, we actually have to give it an additional flag because we're going to proxy that traffic through the Jupyter session itself. So in order to do that, we actually have to tell panel to allow WebSocket origin, which basically is just allow traffic that originates from this address to communicate with my application. So we'll touch again on this a little bit later, but because we're running this Jupyter session at this address, we need to allow panel to we basically say, hey panel, you can accept traffic coming from this address, and it'll toss out traffic coming from any other address. So this is just a security measure that's in place to make sure that the originating traffic is coming where you think it is. So since I am running inside the Docker container, I'm going to copy this command. And actually, I'm not going to copy it. I'm just going to type it out because I've done this a bunch. So again, that command is going to be panel, which is the HoloViz Python package that can be used to start a web server. So we're going to do panel serve, and that's saying, hey, serve this next file as my actual web server. And then inside the interactive Sentinel-2 directory, go into the notebooks folder, and then start that data intake MS Planetary Computer notebook. So right now we just said panel serve this notebook as a web server, and then I need to do the double hyphen allow WebSocket -origin equals 127.0.0.1 port 888. And then if I hit enter, we're going to get, well, it would help if I actually did that correctly. 2 L's would help. Cool. So let me move this over just a little bit. So this is actually going to start up a web server. It spit out an address right here. for the actual web server that it's running. If I click on this link though, it's gonna say I can't find that. And that's because it's trying to go to localhost port 5006 on my local machine, but we're running this web application inside a container. So it's actually not on my local host. It's inside the container on my local host. But what this Jupyter server that we started has a plugin or an extension known as Jupyter Server Proxy that allows us to use the Jupyter server itself as a proxy for that traffic. So I did include a link in the notebook right under that panel serve command for the actual URL that will load up the website. So I mentioned before that this notebook was developed to be used as a teaching tool on how to create interactive dashboards. So it's got some things in it that you typically wouldn't do for, you know, like a real live web server. So it's going to take a little bit for this thing to actually spin up and to show us some output. So we're going to go through this basically every time we start this this panel serve command. It's going to take just a minute to actually load the content. And that's because it's executing the notebook. And if we go back into the terminal, we can actually see it's throwing out a bunch more output. This notebook uses Dask underneath the hood to do some data processing. So it's actually starting a Dask cluster for us. So started up a Dask scheduler. There is a Dask dashboard that we could actually access through that same proxy. The syntax would be the same. So again, we basically append before the port this 127.0.0:8888 /proxy/, then with the port number of whatever we started. But anyways, it's starting up a bunch of things. It's doing a bunch of the underlying computations, but we're getting output from the log of the actual web server here in our terminal window. We can kind of see what's going on. So after about a minute, you can see that it's actually rendered the full notebook for us as a web server. So this is really cool. We've got a full web application that is basically an executed notebook. It's got everything that we want. Again, it executed all of the cells. So before, when we were looking at the notebook, it didn't have this nice output for the size of the data array from Xarray. If we go to the bottom, it's got some nice pictures. These are the actual images that are used for the Sentinel-2 graph. So here's one of the plots with a slider in it that we can now use. But ultimately, what Pritam had done with his original notebook was he got to the end and created these 4 different panels to do different seasons, basically, right? So we've got a winter, a spring, a summer, and a fall with sliders, and you can move these sliders around and it's going to change the image for us. Again, this is all running on a web server via panel. So this is all well and good. I think that there is, certain use cases where we're providing an entire notebook as a web server could be beneficial. But sometimes you want to cut through, some of the crust and take off, the things that we don't want people to see and potentially just provide the last 4, as a website. So panel actually provides us a way to do this. And so what we're going to do is we're going to Control C and exit out of this web server. We're going to change the notebook file just a little bit, and we're going to restart it so that we get just these 4 season panels in the actual website instead. So we're going to, again, kind of cut out some of the explanation, some of the code and things like that to present a more clean cut looking website with something that we're just interested in. So again, in the terminal, let's go ahead and hit Control C, Command C, I think on Apple, and close that out, so that we get back to just a regular terminal. So
Keyboard interrupt.
yeah, you get that keyboard interrupted, and we're still in that IS2 cookbook dev. So instead of rendering that whole notebook, Panel allows us to add this .servable command into our content and serve only what is tagged with that .servable command. So what we're actually going to do is go ahead and go to this notebooks directory and go into the data intake planetary computer folder, or sorry, the notebook, and scroll all the way to the bottom to get to this last cell that actually contains code. So you should get the winter, spring, summer, fall dates to start with the plot, and then at the bottom there's this pn.column command. So at the very end of that parentheses, we're going to add in .servable, and we're going to do open and close parentheses to get that all finished. And what we're going to do is go up and save that notebook to make sure that Jupyter Lab picks up our changes. And so we added that .servable, and we're just going to go back into the terminal command. I'm going to do an up arrow to get back to my panel serve command for that notebook. And we're going to see how that .servable command actually changed the website.
And maybe it'll go a little quicker this time.
No, it's about the same. So it's still going to execute all of the contents of the notebook as it runs through, but it's only going to display what we flagged with that .servable command.
Okay, so you could speed it up maybe by getting rid of some of the other stuff from the.
Yes. Yeah. I do have a disclaimer on there, and I've mentioned it a couple of times. This notebook that we're using in the workshop was developed as a teaching mechanism. It was not developed to be an optimized web server. We did just create an example for the Project Pythia cook-off last week that would be a little bit faster, and that I would probably use in future workshops instead of this. But I wanted to use an existing example that anybody could go out there and kind of pull down, and that was present and worked for this example when I came up with this workshop a little over a month ago. And I will say that out of that that cook-off that happened last week, it changed the context of this workshop a little bit. So I have changed the layout. Before we were actually, so like my original email said that you needed a Python package called nbconvert, and we were actually going to convert the notebook to a Python script because I didn't realize that you could actually just serve the whole notebook like we just did. So I learned that last week. And then I also learned that by adding that .servable command, you can now see that, hey, we only got the 4 plots at the end of that notebook. So again, I can cut out all the code, all of the explanation, and I can provide a dashboard, that contains just the panel applications that I want my end user to interact with. Again, I can use the sliders. It'll update the pictures for the date with the satellite image that was taken on that day. But I could also use this, right, to add in maybe some markdown that provides a little blurb up above that says, hey, the following plots are Sentinel-2 images taken from a satellite, and provide some more context around what this actual what these plots are and that type of thing. But I wanted to show off how you could serve basically the whole notebook, and then how you could trim that down to being just one code block from that as well. So this is the website that we're going to go ahead and containerize now. So we're going to jump into that. So first steps have really just been about basically getting set up, getting this notebook running as a web server, and then trimming it down to something that's a little bit more bite size and might work better as like a interactive dashboard that you would host as a website. So next step is going to be to build a container. So I'm going to go ahead and close this window out. I'm going to pause for a minute to see if there's any questions. I have not looked at the Meet chat in a while, so forgive me. Something popped up in there.
Nick, it could just be because I have a slow laptop, but I still haven't gotten the web server to fully start up yet.
Okay.
I was curious if we could look just at the log output just to see what how long that log output is to get an idea for how close I was.
Okay.
Or could be.
Yeah, so Brian, typically what I see is it'll start the Dask cluster. So you get a bunch of stuff relating to Dask, and then you'll get this Microsoft Planetary Computer. And this is where it's going out to the greater internet to get the images. So this might be where it's taken a little bit. So it's going to pull those images down. And then you'll get, when it actually starts running through some of the notebook content, you'll see some of these invalid value encounter to divide errors. But that, I think, after it kind of pulls down all those images and that type of thing.
Okay. And
so
my guess, it's not caching. It's basically, it's not checking to see if those images are downloaded already. So you're
No.
always re-download every time you start up the server.
Yep. And again, I think that's the way that the notebook was architected, because it's, you know, the nature of cookbooks and those types of things. So just again, this example, it works, and it's a really cool dashboard. I think just to show off what we've got. But there are, if you were developing this to be a pure web server, there are different design considerations that you would take into account when you're building this up. And I did see a comment in the chat, I believe from Ryan, asking if there are ways that you can spruce this up. And there are ways via panel that you can do that. I'm not going to go too into depth about how to do that. You can see that the notebook, when we did the notebook too, it added like a nice little blue bar at the top with the notebook title. So there's ways that you can add that in. I think that you can look further into the panel documentation on how to do that. I know that you can also include HTML to basically spruce up, you know, your website with some HTML and CSS in the background as well. So you can do it with that. You could also run this in Flask if you wanted to, and basically have Flask, you would return the panel dashboard and display that in like a return command and pipe that into your Flask code. So if you're, I'm more well versed in Flask than I am with panel. I've been using panel a lot more recently to do some of these, just because it already exists and there's some existing interactive visualizations that already use panel. So I've been kind of getting up to speed with that. But my background is mostly in Flask. I do a bunch of my web development and stuff in Flask. I really like it. And I do think that you could, you know, run your Python command in a Flask app and do a return, you know, this panel dashboard and display that embedded in your Flask application instead. So, let me see what else we got.
Yeah, it just takes a while.
It does take a while, and I do apologize for that.
Actually, mine ended up 500 internal server error, and I think the reason seems to be event loop was unresponsive. It probably timed out because of all of the large chunks of data being downloaded. I'm not sure if I should go ahead and restart the panel server command in this case, or Is there any better recommendation there?
No, I think if you refresh the web page, it should just kick everything off again. And ultimately, I think this is good for me to take into account for the future workshop. Again, I have a new example I think would be better, but we just wrapped that up on Friday. So short timeline, I didn't want to change everything last minute to use that example. I think that understanding the concept is more important than actually being able to get the application to run on your machine. So my apologies that that's not running properly. It does seem like the application starts. I would refresh the page and see if possibly that it does load. But it's not required to go through the containerization steps. So we can move on into to containerization if everybody's okay with that, without having the panel application fully rendered on everybody's laptops or computers. Does that sound okay to everybody?
Sounds fine.
Yeah, and it does not start doing anything until you open the link. And again, if you're inside the if I use this localhost link, the one that's actually posted when you start the command, you'll get a localhost. This site can't be reached. So the 500 error means that it basically was able to communicate. It should sit there and spin for a pretty long time. But if you got a 500 error, it's possible that it timed out grabbing the data. And I will say that in my previous runs, when I've done this at home, I have had some 500 errors. I don't know if there was, some issues going on with the site that's serving these images or something like that, potentially too. But for me, refreshing this page has eventually worked. But I also have a pretty good internet connection at my house, so if it's that I would think that that's potentially the cause there. But
Yeah. For me personally, I have a really slow DSL connection and the web page times out. And then when I refresh that page, it actually starts re-downloading everything.
yeah, yeah.
So I don't think I may ever get to see this page just because it takes so long to get the information.
Yeah, so that's again really good feedback. This I didn't preface. This is the first containerization workshop that we've run, and my background is not in education. So in terms of teaching, leading this class, I appreciate all of your patience. So I'm sorry. I don't think ultimately though that will get in our way for when it actually comes into creating this as a container. We've got all the files that we need inside this environment. So we can go ahead and get that set up. We can build a container image, which is really what we wanted to do, for this whole kind of workshop. That was really, this next part is what we're trying to get to. So if everybody's okay, I'm going to move on to building the application in a container. And I know we're a little past when I said we might take a break, but once we get this, the container image starting to build, that's a good time to take a break. So we're going to blow through this real quick, get the container file in there, and I appreciate everybody's help in the chat as well. So thank you for everybody's help working together. So last chance for objections to move on to the container build. Awesome. So next steps, we're going to build this application in a container. I did put a note at the top here that the commands Docker and Podman can be used interchangeably. Docker's added in some things lately with their build agent that does have a little bit overhead, but for the most part, they are interchangeable. Inside this Jupyter Lab container, we're going to use Podman moving forward. So we only really need 2 files to run the web server. We need the notebook itself, and then we need that environment.yaml file with all the Python applications that the notebook requires to run. So this next cell block is basically going to move those out of the directory that we cloned. So it's going to create a web application directory for us. It's going to move those interactive notebooks in the YAML file back into that base directory, and it's going to remove the interactive Sentinel-2 directory. So that, and this is basically so that we can push these changes up into our own GitHub if we want to utilize GitHub Actions. We might not have enough time to get to GitHub Actions today. It is included in the walkthrough. So I'll try to, I don't want to go too fast because this is really the most important part. But I did set this up so that we can do that in the future. I will let you know that before running this cell, make sure you're back in the original directory from your forked repository. Otherwise, it will throw an error that it can't find these files to move and remove. So I'm just going to run this whole code cell. If I refresh the file browser, we can see that it removed the interactive Sentinel-2 directory, so that doesn't exist anymore, but I have this web app folder now, and it contains just the 2 files that we are interested in for this web server. So again, we did that to make sure that we can push those files into our GitHub. We don't have a nested Git directory inside of our Git directory. It won't allow you to push a Git directory inside of a Git directory. So we've talked a lot about different containers and things relating to containers so far, but I did want to take this as an opportunity to really kind of level set what a container is and provide just a brief couple of sentences on an introduction to containers. So what you can think of as containers just package software and dependencies into a single image that can be run on any operating system platform that has the container engine installed. This makes it really nice to pick things up and move them around, share them. You don't have to worry if somebody's running Mac OS or do you have this package installed. You got a container engine, here's the container image, you can run it. It contains everything that you need to run. It also eliminates a lot of fluff that would come along with like running a virtual machine, right? So containers are a type of virtualization similar to what a virtual machine is, but a virtual machine contains everything that an operating system needs to talk to the hardware and everything like that in the back end. So container does not contain any kernel information, drivers required, anything like that. It relies on the container engine to create that interface back to the operating system. So the other nice thing about containers are they're immutable. So meaning that once you create a container image, that version of the container will not change inside. It will reliably run in the same state years from now, which makes it just an awesome tool to reproduce and share things across to different people in your organization. It makes it a great way to collaborate. I think that the container that we're running this whole workshop in is a great example of that, right? We didn't have to install Mamba or Conda on your laptop. We just had to have Docker. And Docker contained everything. This Docker image contained everything that we needed to run at the right versions, which was a lot easier. Unfortunately, if you went through the software installations yourself, right, it takes a while to install all those different software packages. I ran through this with somebody with a new laptop in preparation of this workshop a couple weeks ago, and it took me and him over an hour to install all the different software packages, make sure they were configured correctly, those types of things. So anyways, that's just a real brief introduction to containers. Basically, your container image is created from what's called a container image file. And most popularly, you're going to hear this referred to as a Docker file. Again, that's just because Docker is the most popular. So it is kind of the de facto name for container image files. You can name a container image file whatever you want to. Docker file is what Docker and Podman look to by default. But you can specify what file to use with a flag. So we'll get into that in just a little bit. But so at the core, though, a container image file is just a set of instructions on how you want to build and run your application. So this includes, what's the base image that you want this to run on? If it's a Linux system that you're developing software with, you might want to start with an Ubuntu package. If it's a C++ application, you can start with a C++ base image. There's a base image for a variety of different software applications. Again, there's an Apache one if you want to run an Apache server. They typically contain the typical things that you would need to use for your base step. But so the next step that we're going to take here is we're actually going to create a container image file. I've included all of the different instruction steps down below. So we're going to basically copy and paste that into a container file. And then we're going to go through each one of those lines step by step to explain what it's doing and touch on container layers for a bit. So the next steps are to create a new file. So we can do that by just right-clicking over in the file browser. It creates just an untitled.txt file by default. I'm going to name mine just container file. You can, again, name it whatever you want to. But I've been using container file lately because it's descriptive. And then I'm going to go ahead and copy this entire code block here.
You're calling it container file?
Yep.
And just capital C.
Yep. And again, you can dot this out with .dev, .prod, .test, anything like that. It'll work. Appreciate you thinking. So anyways, we're gonna copy all this in.
Just got a quick
Go ahead.
question comment. I tried to do the make their web app delete all that stuff, and it worked, but I still have the interactive Sentinel folder. And every time I refresh, it never makes this web app.
Okay.
And then I run it again and it says, well, you can't, the file exists and you can't delete this because these things don't exist, but they're still here.
I wonder if you might be working in a different directory. Like this might be open in a different directory. So like, let's click into that for just a second. And then maybe even into the notebooks. So it does look like it copied that.
Well, I made a copy of this one.
Yeah.
So, yeah.
Yeah. And let's click on this, the regular folder. Let's go all the way back to the base. Oh.
Yeah, it's really weird. I don't mean to take too much.
No. Go ahead and click into that one. Let's close this out. And then double click that one again. And we'll scroll down and just see if we run it. Potentially, maybe it was. Yeah.
And I tried this counter reset. I tried
Yeah. Go in the terminal real fast. Control C. We'll close that one out. Cool. Give me a ls.
Yeah, still won't let it go, but it's still, it won't let me delete it.
So let's go ahead and do just run those commands directly in the terminal right here. So just copy and paste those without the exclamation point though.
That's right.
So that
Okay.
exclamation point is used
Jupyter only, right?
yeah, to run those commands in the shell. So
I'll give that a try.
So anyways, created this container file. I'm going to copy these contents. I keep doing that. Let me see if I just copy this cell. I'm going to paste those in. Cool, that worked. So we're going to go through each one of these commands real quick. And I'm going to, so the whole container application that we have here is ultimately just 8 different lines. And those 8 different lines each start with these capital commands. And these commands do a number of different things, but in containers, these lines are also referred to as layers. So when we actually build this, it builds each line individually as its own layer, and then at the very end, compresses those all together to create the image, the final image. And then this is an important concept to touch on, because let's say we wanted to add a new package into our environment.yaml file. So we add that in, we save it, we rebuild the image. It's going to say, I've already got this layer built and cached in my system, so it's not going to rebuild this. It's already got this layer cached, so it's not going to rebuild this layer. It's going to reuse these first 3 layers because nothing changed. Now, when we get to this 4th line, the environment.yaml file changed. So it needs to update this layer. So it will do that, and then it will update each subsequent layer. And I wanted to touch on that first before we get into each different line, just so that you can kind of visualize how when you're rebuilding images and you're doing this multiple times, where you place things does matter, because you can greatly speed up your builds. Like, let's say you're changing like the app file all the time. Put that as far down in the instructions as you can, because that will when you on each subsequent build, it will reuse the original layers and speed up your subsequent builds and make them a lot faster. So I just wanted to touch on that before we go through each layer. So the first layer is this from command. And what this is doing is it's setting the base image that we want to build our entire container on. So this application is going to be built on type of micromamba. That is because we have a Mamba environment that we need to activate. It's a Python application. So this fit what we needed to do really well. The Jupyter, so this Podman image that we are running on, I used the Podman default image. I don't have that open, so I'm not going to waste time. There's a Ubuntu official image that gives you a full Linux environment. There's a Python one specifically too. Like, if you don't need Mama, you can run Python. So again, there's a ton of base images out there that you would pick for your specific application. We picked the micromamba image because we're running a Python application that has a Mamba environment that we need to install. So the micromamba image for this made the most sense. So that's the first layer.
So is this going to be Linux, or is this going to be, what kind of container is this?
I believe it's Linux. We can check once we get it built. I can show you how, but I'm pretty sure this is a Linux container. I think the Mamba org container is a Linux-based container. So, and to touch on that too, this container image has its own associated container file that's maintained by the Mamba org. So they have a container file that will look similar to this. It would, on the first line, it would say from, Ubuntu, use Ubuntu latest as the image, and it would have its instructions for installing Mamba and doing all of those things. We can leverage that so that we don't have to go through all of those steps. They already did it for us. So we're going to basically use that as our starting template. So, and that's what you get from these base images, right? You get some kind of configuration that's already in place that you can then utilize, so that you don't, like, we never install Mamba into this container because the micromamba image that we're using already has that installed. So again, this is something that if you're not sure what container image to use for your application, searching the internet is a great resource for that. A lot of trial and error has gone into these things from my perspective as well. I think a year ago, if I had tried to build this container image for this particular application, I would have used just the Python base image, and I would have used pip instead of Mamba. So these are things that I've picked up by building these images and kind of doing a little bit of trial and error. So so that's the first one, and it's important again because that's our template that we're using for the rest of these commands. So the micro Mamba image uses the Mamba user as their user by default. So the next line here is we're actually going to switch to the root user to just do some following commands because we'll run into some permissions when we try to create some copy over some files with some permissions already in place and these types of things. So we're just going to switch to root user. That's what this line is doing. So that layer is pretty small. We're just switching to root to make sure that we don't hit any kind of file permissions like permission denied. You can't copy these kind of files. So the next layer is setting our working directory. So this is now going to become our current working directory for everything that we do in the future. We're going to be working out of this directory. And you can see that comes into play when we run this copy command. So we're running copy. We're going to run a change ownership command at the start of that to make sure that when we copy in all of these files, we're changing the ownership from whoever they currently are. At this point, I don't even know. It could be the Jovian user. We could do a LSLA to take a look, but ultimately, we want these to be owned by the Mamba user, which is, again, the default user in that Mamba container that we're using as the base when we get in there. So, and then we're going to copy the web app notebook and the web app environment.yaml file. And then we provide the dot at the very end to say, just copy them into the current working directory, which again is that home Mamba user app. So at this point, we've copied in the two files that we need to run the web application. The next thing that we actually need to do is install the Mamba environment, right? That's kind of, the other thing to mention are these are steps that we've kind of done throughout this workshop so far too, right? Like we copied the Git repository with the notebook. We installed the Mamba command using Mamba environment create. So these are all things that we've done already to just run this as we normally would. So a container file instructions can be thought of just like, typical steps that you would do to get off the ground and running from a bare bones environment. Like this is how I would get started to do these things. So again, they mirror pretty close to what we've done. The only difference is like, we moved these into its own directory so that we didn't have to copy them in directly. Like, so we could put these in GitHub. We could have copied these directly from the Interactive Sentinel-2 directory with the same command. We just wouldn't be able to push that up into GitHub. So anyways, after we create the environment, we want to run this expose port 5006. So I didn't mention it. I touched on it quickly, but I didn't really explain. Panel by default, when you run that panel serve command, it runs on localhost port 5006. That's just the default for panel. You can specify what port you want to run on, but we at this layer in this line of the container file, we're saying, hey, you need to actually expose port 5006 to outside the container so that we can actually get in there and talk to port 5006, because that's how we access the application. If we did not expose that port, we would basically, even if we run the command, we wouldn't ever be able to access the container, and we wouldn't be able to access the contents inside of it. So this is exposing it to outside world. The next command is we don't want to run as the root user when we actually start this container. So we're going to switch back to the default Mamba user, which is what the Mamba container again uses by default. And then this last bit is actually the command that we want to run the container, or like what command to run when the container is run, right? This is the actual web server. The command is provided in a list. So you can see that instead of just doing a big quote with the full command that we put into the terminal earlier. We actually had to break this up. So we've got, you know, quote panel, end quote, comma, quote serve, end quote. So you have to break up anything with spaces in between, basically becomes its own like quote. And but yeah, so anyways, that's the 8 lines that are needed to run this application in a container. So we have now built a container file that contains all the instructions that we need to run this application. And again, they mimic very closely the commands that we did to run this before outside a container. So we're gonna save this file. I'm gonna close out of it too, just because, actually I'll leave it open, and I'm gonna pause here just to take any questions about the different layers, using base images, anything that I'm doing here. So it's, Carol is saying in the first layer, base image feels like more a base environment for Docker. Why is it called a base image? And that is because it's actually a container image. So when we run the build command, the first thing that it's going to do is it's actually going to pull this container image, Docker IO, Mamba org, micro Mamba, down to our Jupyter instance. So this is, in fact, a container image, and we're using that container image to build on top of. And that's why we use that base image instead of base environment. Because this micro Mamba is a container image that's provided by the Mamba org, and it's hosted at Docker Hub. So I think if I just search real quick, we can see that here's a little bit more, and let me make this bigger for everybody. So we can see this has got some information about the different container. It's got a command on how we can actually pull that if we wanted to run it on our environment. It's got a bunch of different tags here. So we specified latest in our from command, but you could also pin this to a particular version if you wanted to as well. So Brian, you can go ahead and unmute.
Yeah, so I guess it's like bigger than an environment specification, really. This is a question, but it's like it's an emulator for an operating system that you're basically pulling down there. It contains Linux and all the commands you would need for Linux and all that stuff, right?
Yes. It doesn't have to necessarily be an operating system. They can get pretty thin. Like I'm pretty sure the Python Slim version is just like the Python Rebel. It's probably built on some other version of Linux, right? Because Python itself isn't an operating system, but it does provide you some level of operating system under the covers, but it's fairly thin.
Okay.
And again, I think it will depend on the container that you're looking at. So I guess a good example, right, is the container that we're actually running in. You can see that this is a Linux container. I use the Podman official, and Anna's got a good comment. A lot of the minimal images are things like BusyBox or Alpine Linux. So like very minimal operating systems with not a lot of bloat and not a lot of additional packages. So thanks, Anna. And then the previous Jupyter Hub images that I use the Ubuntu 2204 image as the base, and that is an Ubuntu 2204 operating system. And when I get in there, it works and looks very much like an Ubuntu 2024 kind of OS. The Podman image that we're running here is a Fedora-based image, and that's just what the Podman official image is built on top of. So they switched. So under the covers, this is a Linux operating system but it is Fedora based. So I had to switch from apt-get, right? I was installing the container file for my typical Jupyter Hub images. I will have a command down here that will say like run apt-get update, run apt install git, run apt install Python to install packages that I need. But when I switched to the Podman image, Fedora uses Yum instead as their package manager. So I had to switch all of my installations from apt-get to Yum. So you do need to know a little bit what's under the covers, like if you're gonna install additional packages through like an OS package manager. But it is most often it's going to be some kind of thin Linux operating system. Any other questions? Because the other thing I didn't touch on because we didn't need it for these layers is each one of these layers is just one line, but you can have multiple lines in a layer. And you typically just do that by running like a ampersand, backslash, and then on a new environment, like I could do, like print env, and it would print out my environment variables, those types of things. So you can change your layers together. This makes sense, again, like if you're running apt-get and you want to install, every single package all in one. And then you can basically say, keep installing all of these packages in this one layer instead of running a different layer for each package install. So you can get that granular. There was one more comment. And are you looking for like just the container file that I use to build that in general? So I do have that, and it's in a different repo, so I can share that out if you're interested in that container file. But yes, I can share that, and I can put it in here. Yeah, I'll include it in this this repository that we forked. So moving forward, that'll be in there so that people can have that. Because again, it is cool having a Jupyter environment where you can run Python Podman builds inside of it. I have not gotten it to work in a Jupyter Hub yet, but I have not spent a ton of time testing that out. But so anyways, we've got this container file. That looks good to go. So we're going to build the container image next. That's the next part in the walkthrough. So I'm going to just copy this command right here. And then I'll talk through it on the terminal here. So again, I just want to make sure I'm in the right working directory. I want to make sure that it contains my container file and not fat finger. All right, so the command to build your container image is simply just going to be podman build. In Docker, it is Docker build. I think they just they added in a new build component though. So again, I think with Docker, you have to do Docker build X build now, which is kind of redundant, but anyways, but it is just podman build. And then I give it this -f to provide the file name that I actually want it to build. So hey, look at this container file. Podman by default will look for Docker file or container file. But for instance, I could name this container file .test, and I would use this .f flag to say build container file .test. Instead of container file by default. So that's what the -f flag is. That's basically just use this file. Now the next one is -t, which is tag. So we're going to build this image. What do we want to name it? What do we want to tag it? So I'm going to use encodey, which is my Docker Hub. Actually, I'm going to change this. encodey is my Docker Hub account for my UCAR system, but my personal Docker Hub account is ncginge. So I'm going to use that instead. So I'm going to tag it with my Docker Hub namespace, and then a / and then a container name. This can be anything that you want to. I'm calling it nbviz to container because that's what this workshop was titled. But again, you could name it, workshop image, whatever you want to. And then you can add a colon and, like maybe today's date or something like that if you wanted to provide version control to your image. If you leave it without a colon, it tags it as the latest by default. So I am not going to provide a tag. I'm just going to just use the latest. Then
Hey,
go ahead.
can you please explain again where NC Ging is referring to?
Yep. So ncginge is my Docker Hub username. So if I go ahead, sign into Docker Hub, this is my personal email address. Feel free to send me a message. And I go sign in. You can see right here from the dropdown, the namespace for my Docker Hub is ncginge. So that is my personal namespace.
Yeah.
You
This is
can.
where we need a Docker Hub account, right?
Yeah, we're gonna get to that possibly in just a minute. We're gonna see how we do on time. We're getting close to the end here. I actually have to cancel a meeting real fast. Wasn't sure how quickly this was going to go, so forgive my inbox. So right here, you're tagging it for your local system. So if I wanted to, I could just do test. And this would just, that would be the container image name. The full image name will actually be localhost /test /nbviz to container : latest. And we'll see that when it's done building. And sounds good, Orhan. And for anybody that has to leave early, I did include my email address at the beginning of these slides that I kind of kicked off. So I will provide those to Tasia, and feel free to reach out to me after this. If you've got something that you're interested in containerizing and you need some help getting started or those types of things, like I'm always here to answer questions and help out with that kind of stuff. So outside of this workshop, let me know and we can get that done. So anyways, that is the full container name. Again, we'll see it at the end. The last kind of like thing when the build finishes, it'll say successfully tagged localhost /test /nbviz to container : latest. So we provided the name that we wanted to use. And then I do dot because I want it to build out of the current directory. If this container file was in web app, I would do web app /dot to have it build out of that directory instead. But we're building out of the current directory, so I don't even flag that. And then I provided this -dat format equals Docker because the container file that I have is got some run commands that run out of the shell, which is not compliant for the OCI format. So I need to basically say, hey, the format of this container file is Docker. Otherwise, we'd hit some issues. And some of that is my own nativity from coming over from Docker to Podman recently. And I need to actually do some more investigation and figure some of this stuff out on my own. But the -- format equals Docker command for Podman will let this build. So I'm going to kick this off. It's going to take a while. So this is another time to take a break. And just let me know if you have questions.
Do we need to change anything in the container file for the working directory or anything like that? Just keep that generic.
Yeah.
I right away ran into an issue.
You get the cannot clone.
Yeah,
Yeah, me too.
invalid argument.
Yeah. This guy down here. I even tried to Make sure I had my own Docker Hub one.
What's your working directory?
Should be this one. Excuse me. Yep.
Not used to talking this much.
That's a drain, isn't it?
It
That's
is.
crazy.
Is anybody else getting that command?
Yeah, I am.
Yeah, we're getting a bunch.
Okay, everybody is. Did you start this container with the privilege flag?
I think so. Let's see, where would that be in my? In the Podman build one?
No, from go back to your actual terminal, your Mac OS terminal. Let's go up. How to start? Where you ran the actual Podman.
This guy here.
Okay.
Docker run privileged.
Oh,
Hmm.
So that is it's an issue running the rootless Podman build. So I'm not sure why it's working on my laptop, but not yours. That -- privilege flag should allow it to build, but it's not able to. So again, this build takes a little bit. And if we're gonna hit that issue, I think we might switch gears real fast and go into creating a GitHub Actions workflow to build a container for us.
So, yeah, somehow, so that's a permissions
It's a
issue.
permissions issue with the Docker build itself. So
And not a re-exec process.
clear as mud, right?
Yeah. It's like the errors that all my code generate.
Warning, this doesn't work. Great, why?
and I know it's because of that privilege flag, but well, it's because we're trying to build Podman inside of a Docker container.
Okay.
And that -- privilege flag is supposed to allow it to run that clone command, and I'm just not.
It's the nesting Russian dolls. have
Yeah,
gotten
the
too
containerization inside of containerization stuff can get a little bit tricky. Again, I was trying to make the prerequisite stuff a little bit easier to digest.
I'm curious if anybody got it to run.
Did anybody have success, or speak up if you did? I do have another workaround that we can do.
Well, somebody's
success.
okay.
Okay, so
They're better than we are.
I'm on Windows.
I'm on Windows too,
Yeah, and we're all on Mac.
Yeah.
but I'm also running my Docker command from inside my Windows subsystem for Linux. So I'm running.
Well, Ryan's
Yeah.
is working on Mac, so that's not a problem. Guess we didn't ask politely enough. Should be -- please.
Yeah.
Yeah. So we can pivot. So what we're going to do is, this was the next step that we were going to take anyways. We were going to let this build finish, and we were going to run the container, and we'll still do this. We were going to run the container and see that we get the same application, right?
So in theory, I could do this, but not inside the Docker thing, just
Yeah.
the original plant
Yep.
with all the stuff installed.
So instead of reworking it, what we're gonna do is we can go over to this extension, the Git extension, and we're just gonna hit this plus button to track all these files.
Oh, yeah, just the ones that are untracked.
Git extension, no, hold it. I was on the,
On the left side, the little diamonds with the branch in it.
yeah,
So you
yeah,
click on that.
yeah.
That'll bring up, and it'll have changes. So there'll be something that says untracked. And it'll have the container file and some of the things. So there'll be a little plus next to that.
Yeah,
So just hit that plus to add all of the files into staged.
okay. Staged.
Yep. The walkthrough, mine says it's changed because I ran some of the cells. So I'm actually just gonna discard the changes. So, because I don't really need those.
Okay.
Um,
Change, discard, how do I do that? Discard all change.
there's like a little loopy arrow.
Yeah, the loopy arrow, I
Yep.
got that. Okay. Change 0. Staged.
Yep. So you should have the files in the staged now. Down below, there's a little summary bar. Just added a commit message. I just said added container file. And then there's a blue box at the bottom that says commit. And if you're more familiar with doing Git from the command line, that's perfectly acceptable too.
So this is like a git add.
Yep. Yep.
Okay.
That's all it's doing. It's just a UI way to do it.
Who is
But-
committing?
Yep.
Do I have to fill in myself?
I usually do, because you are pushing it. We're gonna push these changes, so we're gonna push it back up to the fork that we did. And then I'm seeing this building over here on the side. So just to point out, there was a question earlier about the name. So you can see that this last little bit says, hey, successfully tagged the image as localhost test nbviz to container latest. I do have a note in the walkthrough, and I'll take a minute just to touch on this, that you can retag the image with whatever you want. So you can just do this with Podman, tag the image name currently, and then the new one. So like if I wanted to push this to Docker.io, I would say, or to Docker Hub, I would say Docker.io. Then I would give it my namespace and the container name that I wanted to give it. And then I could also add a tag instead of latest to do some version control. So again, I can do 2024, 06, 20, today's date. So Podman threw out some warnings about deprecation, but it did tag that. So if I do a Podman image ls, you can see I've got one named localhost test and then another one named Docker.io. So these are actually the same image. It's not recreating that. It's not using up 8 gigs of space. It's only using up 4.5, which is still fairly large. But again, we could slim that down by doing some things with the notebook and making that a little bit smaller. But you can also see here, it's got docker.io mamba.org micromamba, which is the base container image that we used for the build. So it actually pulled that down to my local system. And I ran this a couple days ago, so it did it 3 days ago. But for you all who, if you were successful in building the container image, you would see this listed as well as the container that you just built. So that comes back to the earlier question we had about base environment versus base image. So this actually is using an image, and it pulled it down to my local Jupyter Hub instance here. So anyways, to get around issues building the container, we can stage those changes, add a commit message, commit those to the branch, and then push the changes if we want to. Now, you would get this from the command line as well. It is going to ask for my username, which I'm using my personal one, and I'm gonna for those who have never created a token before, I'll run through that real fast. So in your personal GitHub account, in the upper right is like your icon for your username. If you click on that, in the drop down, very close to the bottom is settings. So if we click on the settings page, we'll get taken over to our settings profile. And this is all included in the notebook too. So that'll be there for posterity. But once we're in the settings page, we're going to scroll down all the way on the left until we see this developer settings link. We're going to click on the developer settings. The nice thing with the links that I provide in the notebook too is this link is the same for everybody. So you can see there's no, it doesn't have my GitHub username in here or anything like this. So this link works for anybody. And then in here, there's personal access tokens. And we can create a token to use to authenticate our push. So we want to go in here, generate a new token. It'll ask for your password. Create a little note. say test 2, ask for an expiration date. If you already have a token, you can use a token as well, that already exists, but, and I'm just gonna make mine expire tomorrow. And so this token will only be good for today. I want it to have access to my repositories. I'm gonna generate that token and you're all gonna see it. So here's my token. This is the only time I'm gonna be able to see that. So I'll copy that, go back in here, use my username, paste that token in. I can click save my login temporarily just in case I need to do something again here shortly. I don't need to repaste that token. And I'll hit OK. And it says it's successfully pushed. So these changes should now be in my forked repository. So if I go back over here and into my repositories, this top one is the forked one that I just changed. And cool. We see, oh, I added the container file. That container file is in this repository. And basically what we're going to do to walk around not being able to build it inside the Jupyter hub is let's clone this onto your local machine, and we'll just run a Docker build directly on the local machine. So let me go ahead. I'm going to start up a new terminal. I like to keep everything in a code directory, and I'm going to run a git clone of my forked branch. So it's going to clone everything. I'm going to cd into that clone, make sure I've got the right one. And I've got the container file in here. So now what I can do is on my local machine, if you have Docker, I'll use Docker. Since most everybody has Docker because we were able to launch the Jupyter Lab container image. We'll do a Docker build x build. We have to provide it the flag for container file because Docker only looks for Docker file by default. So we have to provide the flag here. Podman will recognize container file by default. Docker does not. And then we add in the tag again. So just whatever name sounds good to you, the dot. And we don't have to do the format equals Docker because we're actually building this in Docker. So I can make this bigger. No. No. And then by hitting enter now, it'll build this Docker file on my local machine. So does that work for everybody?
So far I'm missing something. How do I think I just committed it to my GitHub area.
Yep.
I've used GitHub in many different contexts over the years, and I've got lots of different user IDs. I committed to something. How do I get the chain? How do I get the full URL of that GitHub repository from the diamond menu, the Git menu over on the side? I want to try. It said it pushed it successfully somewhere, but I'd like to have the URL that it pushed it to, so I could do that Git clone that you just did.
Yeah, so mine just says up at the top the current repository.
Yeah.
If you're inside that folder, the Git clone, you can say git remote -v and it will show you the URL it's pushing to.
Thank you, Brian. Cool.
That's nice. Thank you. Yep. So, okay, so I can, in theory, use a native terminal on my machine and clone that.
Yep.
And put it. Okay. Git clone this thing. Okay, got it. Lovely. So now you were saying run the Docker build thingy,
Yep. So it's Docker space build X, just the letter,
build X,
space build,
build
space dash F,
dash F
space container file,
container file.
space dash T,
Okay,
and
fine.
another space, and then whatever tagging.
Just test or something.
Yep.
And then dot.
Dot. Yeah.
Okay, see what that gives. Let me see, no container file. Oh, bother.
So just make sure you CD'd into the cloned repository.
Yeah, I did, and somehow it didn't get that container file.
Oh, did you forget to push
Oh, I
after
must
your
have.
commit? I did this.
Yeah, I'm always doing something like that. So let me see. So I got to do git push. Maybe
Yeah. From the Jupyter.
user. Oh,
Yeah.
okay.
And that's where you need the API token like I just went through.
Yeah. Okay. So now I'm stuck again.
Yeah, I'll help you out in just a second. I'm gonna go ahead and run the container inside my Jupyter Lab environment. And I'll go through this real quick. So to run the container, we do podman run. For this particular container, because we're using the Mamba image, we have to specify the Mamba environment that we want it to activate. Otherwise, it'll just use the default kind of image. And when we run it, it'll say, basically, I think the first one that comes up is panel not found. So the actual container image won't run. So we do that by providing this -e, which means environment variable. And then we set the env_name equal to is2 cookbook dev. That's the name of the Mamba/Conda environment we activated earlier. This env name is just something that the Mamba image expects. That's what if you want to change the Mamba environment, you just provide it the name in this environment name variable, and it loads that by default. We give it the -p command, like we discussed earlier with the Jupyter, to map port 5006 on the container to 5006 on the local host. And then we're going to say, run the actual container image. So that's localhost/test/mvviz to container. So I'm going to run that, and it will start up the container version of the web app inside inside a container. So now we are running the same web server inside a container, and we can see that, oh, hey, this localhost 5006, this is the same link that we had before. So we're actually going to go back into the to click the link. It's the same link that we used before. It's running on the same port. It's running basically the same way, but instead of running it as a Python application, now we're running it inside of a container. So again, this will spin for a little bit. It's going to do the same image loading. I'm not sure if it's going to be any faster for people that were having timeout issues previously. So again, apologies for that. In the future, I'm going to change the example to be one that I had a hand in developing instead of leveraging one that was already there. But I appreciate everybody that has to leave. Again, reach out to me at any time. There's some other stuff in this notebook that we weren't able to get to. That's not really wasn't the point of my overall goal here was to provide an introduction to creating a container image file and building a container image. So we did get that accomplished. The next bits are around how that you would push this image to Docker Hub, how you could enable GitHub Actions to actually build the container for you, those types of things. So if you're interested in that, you can continue on through the walkthrough notebook on your own. When time runs out, I'll be here until noon. And if you have questions after this workshop, please feel free to reach out and shoot me an email. And I potentially will get a follow-on workshop added in to do some discussion around using GitHub Actions, because I know that that's a interesting topic to a lot of people. And again, I created a lot of template stuff in the notebook that you should be able to hopefully walk through. I would appreciate feedback on any of this. If stuff's not clear, if there's errors in the notebook, stuff like that, feel free to reach out. Give me some good feedback, good or bad. I'm open to any and all of it, because I would like to get better at leading these types of things and providing content that you all think is valuable. So anyways, this is the container version of the website. You can see it's up and running. It looks exactly the same. But I can then share this with all of you so that you wouldn't have to build this container image yourself. You could just run it right on your own. So here, I'll come take a look. Were you able to get the container to build locally on your machine?
Yeah, I can build it and then I don't know where to go from there.
Cool.
But, yeah,
It's that
build.
so you do Docker run -E space and then all caps env_name
Okay.
equals is2-sentinel-dev. I did include that in the walkthrough notebook. Okay. The actual command to use. And then after that -E, then you got the environment name. Yeah, so it's is2-cookbook-dev. You give it -P 5006:5006, and then the name of the container.
Gotcha. Okay. Thank you.
Yep. So at this point, we built a container image. We have gone through pushing it up to your actual repository in GitHub. So if you wanted to go through the GitHub Actions steps, it's further down in the notebook. There's a section here. Awesome, thanks. The connection refuse can come if you use the wrong URL and stuff like that. So that's why we use this proxy command, because if we do, just like if I go to the container and click on the link that it gave me, it says, hey, you're running on this, like it'll give me a connection refused message because it's not running. So it's not running on my local host. It's running through this Jupyter hub that I have to proxy. So anyways, the next steps in the walkthrough, the next section that we're not going to get to revolves around Docker Hub, how you would log in to Docker Hub so that you can then push this image into your own Docker Hub namespace, and then you could share that link with other people to say, hey, you want to run this web application that I did in a workshop earlier today. Here's the Docker run command, similar to the way that I provided you all with the Podman notebook, command at the beginning. So that is stored in my Docker Hub, so it's publicly accessible. You do have control over whether the images you store in there are public or private. You can do different versions, those types of things. So it goes through what Docker Hub is and how to log in and then push the container that we built into the Docker Hub. It goes over tagging, which we did kind of cover on how you would update the tag of an image you created to something else if you wanted to do that. And then it goes through the push command, which is relatively straightforward. I think the most complicated part of the Docker Hub is just getting logged in and getting an API token so that you can then log in again. So I think we got 7 minutes left. Again, the GitHub Actions stuff is in here as well. So if you're interested in that, it is included. Excuse me. Yeah, not used to talking so much. So I'd like to take the last bit here and just talk through questions or have a conversation if people have anything they want to talk about.
Just quick question. If I was to theoretically log into Docker Hub, and then if I was to use like the same name I did to do the Docker build, it should all be good at that point.
As long as as long as the name that you use in the Docker build is your namespace.
Okay.
If you go to push that, and like say you log in and you go to push it and you don't have permissions, it will throw a permission error.
Okay. So if I wanted to do this better next time, I would have logged into Docker Hub before I did this Docker build.
You don't
It
have
doesn't
to.
matter. Okay.
No. Excuse me. You can do the Docker login whenever. It just has to be done prior to running Docker push.
Gotcha. Okay.
I'm pretty sure if I do this Docker push from this latest image that I gave, I got denied, right?
Gotcha.
So it's because I haven't logged in. And specifically, I haven't logged into the NCGinge namespace. So to get over that, I would just log in, and it would ask me for my API token, which again, I did include information on how to get to that in the workshop, but it's basically the same thing as Docker Hub, kind of, or sorry, GitHub. You click on your name, you go to the account settings. On the left here, there's a security button, and then you can create a new access token. Docker Hub is different than GitHub. It will not give you a Docker Hub does not give you an end date. So these tokens are alive for as long as you have it open. So I would recommend for for this instance, for this workshop, create a token, use it to log in, run your push. That's all good. You can come back and delete it after the fact if you're not going to use it again in the future. It's really easy to lose track of these, so I do like to provide accurate descriptions. So like if I'm using a token for a GitHub repository, I'll give it the repository name here. I typically won't give it delete permissions either. I'll give it just read and write. That'll allow it to pull from my private images as well as push to my own namespace. So that's probably the trickiest part is getting that access token. Otherwise, the podman push is the same as Docker push. The logging command is the same, and that's relatively straightforward. So I would run a Docker login user for NCGinge. I can do that. Yeah, thanks to everybody else. And again, with 3 minutes left, any more questions outside of this stuff? And if I just do login right here, it's going to say password. I think you can use your password. Let's see if I know mine offhand. Okay, yeah, you can just use your regular password.
Okay.
But like I went through this with somebody that used their Google account to sign up for Docker Hub, and they didn't know what their password was. So you can also use the token, that access token, and paste that into the password. That's pretty much it when it comes to creating containers. Again, this is very specific for this example, but you could see that, let's say you were going to do an Apache server. You would use the official Apache image, and you would just copy in the HTML. Apache serves HTML directly out of a specific directory. So you would just copy all your HTML into that image, build it, and run it. If you had, we can take a look. Let me open up. Anna was asking about the Podman image that I actually built for the to run that Podman notebook, and that's what this container file is. So this is for that Podman image. So you can see I use Ubuntu 2204. I set up some environment variables right from the start so that I can use these in the future. Set up my path, those types of things to include Conda. I install all the packages that I want, and I do this out of a an app.txt file. So it's fairly similar to the way that I would install Jupyter Hub on a brand new notebook, or sorry, a brand new laptop. Like if I had an Ubuntu 2204 fresh laptop, fresh install, these are the things that I would need to do to install Jupyter Hub in the fashion that I wanted it. So, cool. That's mostly like, again, how you think of these things. If you gave somebody step-by-step instructions to install something on a brand new laptop, it translates pretty well to what you would do in your container file to build that same kind of image. So. Cool. And Courtney, that sounds good. I do have one that I can run that's specifically around CI/CD for the Sizzle Cloud. And let me stop sharing my screen so I'm not infinity. So I will work with Tasia to set up part 2 of interfacing with the Sizzle Cloud, and that will cover using GitHub Actions to build the container image itself, and then go into some of the cloud-specific stuff around Kubernetes. Again, it's still in that notebook, so feel free to take a look of it ahead of time if you don't want to wait like another month for this next workshop or whenever we get it scheduled. Feel free to reach out, and I don't mind scheduling one-on-one meetings and sitting down and working through it individually as well. No, and I appreciate that. That's always a good thing to keep in mind. And we do have mechanisms in place too, where we can fine tune the amount of resources that people can even get. And we have some things in place to prevent what applications can ultimately be deployed. But step 1 is creating a container image of, the application that you want to host on that Sizzle platform. So. Anyways, appreciate everybody's time today. The meeting was recorded, so we will get that out along with the slides in the next few weeks. So